Hi, my name is Braden, and I've chosen to do my project over a mineral. I've chosen diamonds, actually. A little bit about why I chose it. I've always thought that gemstones and, like those really pretty rocks, I've always thought it was interesting that you could take those rocks out of the earth, take them from the mantle of the crust, and, polish them up a little bit, clean them up a little bit, and almost instantaneously you have a symbol of class and elegance. I was originally going to research another gemstone. I was going to do amethyst because amethyst is actually my birthstone, but I thought that researching diamonds might be a little more interesting, and diamonds are my brother's gemstone, so I thought it would be pretty fitting. What is it? So, as I said earlier, diamonds are obviously a mineral that come from the Earth's mantle. Diamonds are made of 100% carbon, so they're a very, very durable material. Some of the uses that people don't think about for diamonds could include things like cancer treatment, cutting tools, things like that. If you weren't aware, scientists use these things called nanodiamonds, and nanodiamonds are typically smaller than a hair follicle. So they'll use nanodiamonds and they'll inject it into chemotherapy and the treatment that they use for cancer patients. And these nanodiamonds will be used to, destroy cancer cells. So I thought that was pretty interesting. I wasn't aware of that before this research. So the region and location. So diamonds are typically found in diamond mines, and diamond mines are honestly in a plethora of places. They can be found in places like the United States, Canada, Russia, regions like that. I specifically want to highlight South Africa because a lot of these diamonds are located in South Africa, and they'll be in countries like Namibia, Angola, Siberia, places like that. More specifically, the location the diamonds are found in, they're found in these things called alluvial deposits. And alluvial deposits are places where there's a buildup of sand, mud, clay particles, things like that. And this buildup of particles is laid to rest by flowing water. You can actually find alluvial deposits around our campus. Just look for places where erosion and deposition is high, and you might find something there. So minerals. Minerals are measured by two instances of time. So the first instance is going to be relative time, and relative time is usually measured for rock formations, and it's measured by cross-cutting, how the younger rock cuts through the older rock, and that's how they know which one was formed first and which one was formed last, things like that. And then our second instance of time is going to be the absolute age. So absolute age is measured by radioactively decaying materials within the mineral. And through these calculations, scientists can not pinpoint exactly, but get a closer estimate of how old a mineral really is. However, with diamonds, research has been going on for hundreds of years. And they can't exactly pinpoint an exact age, but they can kind of ballpark it. And from all the sources that I've read, they've kind of unanimously agreed that diamonds are actually older than the stars in the sky. And if you really think about it, the stars are millions upon billions of years old, so you can really imagine how old diamonds will be. Preservation. So there are two types of preservation. There's going to be natural preservation and there's going to be human preservation. So as I said earlier, diamonds are a pretty stable material. So as they're being formed and created in the Earth's crust, they kind of have that natural barrier of like rock and soil and things like that. And on top of that, mechanical weathering forces like water, wind, lava can't really affect diamonds because of their stability. So diamonds have almost this kind of natural armor or like natural protection. As far as human preservation, when these diamonds are extracted, they're typically placed in like cool and dry areas with little to no sunlight, and they're cleaned with kind of mild solutions just to avoid cracking, scratching, breaking, things like that. So one of the topics that I wanted to talk about, was actually, it's a pretty self-explanatory topic, but I wanted to talk about heat. So heat is found in a lot of our geologic processes, things like volcanism, metamorphism, evaporation, things like that. But I wanted to specifically relate heat to the creation of diamonds. So diamonds are actually created under an immense amount of heat and pressure. I believe the range for the required heat to make diamonds is between 900 and 1300 degrees Celsius, something like that. So that, on top of the immense pressure of being inside the earth, diamonds are formed. My second topic is going to be kimberlite. So you can kind of think of kimberlite as the parent rock to diamonds. This is the actual rock that the mineral is found in. So there are these things called kimberlite pipes, I believe. And when, workers are extracting diamonds, they're gonna look for sites that are high in kimberlite, and they're gonna get those diamonds out of that rock. Kimberlite is actually an igneous volcanic rock. So when kimberlite volcanoes explode, they're typically rapid paced, they're typically fast, and they're deadly. But in that high paced environment, diamonds are preserved naturally because, like I said, they have that natural protection. And so, when it's erupting, diamonds they don't really take any damage from it. And lastly, I wanted to talk about some of the jewelry uses, or some of the more uncommon jewelry uses that diamonds are used for. Obviously, when someone mentioned diamonds, the universal thought is going to be like a diamond ring or like a diamond necklace. But there are some other beautiful pieces that diamonds are used for. So they can be used for things like tiaras, they can be used for watches, they can be used for brooches. As I said, diamonds are kind of seen as like a symbol of elegance and class, and all of these things are very beautiful and very, very elegant. So I think it's interesting that diamonds can be utilized in such a plethora of ways. All these different jewelry pieces share one thing in common, and it's beautiful. And these are just my citations, which I'm going to upload it here in just a second. But thank you so much for watching my presentation. I really appreciate it.